Hello, GeeCON. Are you awake? Good. Thank you. I'm honored that you came at such a late hour, as you still have power to digest one more presentation. I hope this one will be entertaining. My name is Konrad Szałkowski. I'm a Java developer with 15 years of experience. Right now I work in a company called Ignite, where we care about your data, in short. Besides that, first and foremost, I'm a father and a husband. And even if I have some spare time, I lead Poznań Java user group. And even after that, if I have still some free time, I try to marry GPUs and Java. Weird hobby, however, when everything works, it's very satisfying. Regarding questions, if anyone will have some, please post them on Slido. I will try to answer after the presentation. So let's start. 70 years ago, when software engineer job descriptions started to appear in the newspapers, we were going to the work with the big, heavy books. Those books contained CPU instructions for the CPUs for which we were programming. And we took those instructions, subtractions, additions, multiplications, loading the data to the registry, loading data from the memory, unloading to the memory, jumping to the other place of the code, and we composed the listings of those instructions. And we put those listings, loaded them onto the CPUs. The CPUs loaded the data, processed, and threw out some result somewhere where we specified in our programs. However, the technology started to develop itself, yeah? More and more CPUs started to appear on the market. And we needed to carry more and more fat books. Finally, someone's back finally struck, and he said it couldn't be like this anymore. We need to put some sort of the layer of the abstraction over this machine code. So we started to develop programming languages. COBOL, Ada, Fortran, and BASIC. And those languages were good. We built a quite heavy, quite big enterprise software with them. Yeah? In COBOL, most of the current financial systems are still running. Ada, we put those software written in those languages to the passenger jets and send them flying over the oceans. And everything worked. Even such complicated thing like running Polish railways, management system was written in BASIC for some time. And those languages were good. They were effective. We combined with them quite a big software together. However, when it came to maintaining this software and developing new features for this software, the things started to be cumbersome, and the efficiency of those languages suddenly dropped. And everybody knew more or less what the problem was. But finally, this guy showed up, and he wrote a famous letter. Does anyone recognize him? He's famous, hint number one, he's famous for the two things. First thing is the thing that this letter that I will mention. The second thing is the algorithm which helped you to actually get to this theater, get to this place. Yes, Dijkstra. This is Professor Edgar Dijkstra in his young years, where he actually wrote this letter saying go to. So CPU instruction, which is jumping from one place of the code to the other, which was straight derived from this machine language to the languages which I mentioned, is harmful. It's harmful for the software development and software maintenance. But why? The problem is that goto disturbs order and control of the flow of your program. take, for example, this simple basic code. I bet all of you here are Java, JVM-based languages programmers, but you still are able to read this code, which is very simple. What is being done here is the first program of each programmer, yeah? It's writing up something to the output, writing hello world, writing multiplication, or writing some string concatenation. But this is the second program of each developer, yeah? Take an input from the user and print some output. But imagine that it was simple at the beginning, but suddenly someone came in and he was tasked, okay, we need to change a little bit the flow, we need to output some different numbers, output some different strings. What he did, he actually found a place good to hook up, he placed there a goto, and he went safely to his own piece of program and written down some instructions there and hopefully jumped back. But there was no guarantee of such behavior. I asked AI to generate control flow, like flow diagram of this program. And you can easily hear already that it's quite complicated, the graph itself, and I couldn't see because of those lights. However, I bet that your eyes were jumping in the similar manner around this GoTo-based basic example. GoTo is good. Do not understand me wrong. However, it gives you an enormous power, yeah, and power to write more smaller programs, the programs which are executing more efficiently, and many other things. So it is, in its pure basis, a very good command. I don't know, on the DevOps Belgium last year, actually there was a talk how they written Mario. And there, in this Mario game description, you could easily see how GoTo was used along there. And GoTo gives you great power, but with the great power comes the great responsibility, as we all know. Yeah, responsibility for others, for the people who will be reading our code. When I was at studies, my professor said to me, Konrad, you will write nice code on your own around 20% of your time which you will spend in your job. 80% of the time you will read some others' documentation and most importantly, someone else's code. Right now, with my seniority rising, I feel that I'm reading 90%, 95% of the time. But since 2 years, since the ChatGPT boom, I have a strong feeling that we are writing 1% of our code. Yeah? So readable code is a very important thing. So we have a problem, we have a GoTo. But how to maintain the control? And around the time that this letter was published, the two doctors at Carnegie, as far as I remember, Bohm and Jacobini, came up with the solution to this problem. And they called it Structured Programming Theorem. Do you know structured programming? Raise your hands. I bet you all know, as you are sitting here. Just because structured programming is a 4 simple rules. First rule, the main rule is the code is running within the blocks. The blocks have a clear start, the blocks have a clear end. And there is no possibility to jump outside with the code flow from the block. The code flow changes are achieved through 3 simple and well-known constructs. First of all, a conditional. Yeah? So we have a code block, which is running, which ends, which arrives at the conditional expression, and this expression gets evaluated. And it goes either with the true branch or with the false branch. We have loops. So we have a code block, which is wrapped around with the loop statement. And this loop executes 0, 1, 2, 3, 4 times, n times. All those executions are proper executions of the loop. And the third rule, the most important from the point of view of this presentation, is a function call. Yeah, that we can have a function, like we have a code block, which is at some point calling a function, which is another code block with a clear start, which executes throughout its code, and it ends, and it goes back, what is most important, it goes back with the control to its caller. It's not jumping to the outer space with the code execution. It's returning it to its caller. And this caller gets to know the function result or exception, maybe. This gave us a sense of predictability. Yeah, just as with the traffic. The cars are following certain rules, and you can predict how they will behave on the road. If there will be no rules, we would have serious problems, and we would risk our lives. So these 4 rules gave us sense of predictability. The blocks of the code gave us structure, yeah, because we started to get Lego bricks, which we can put together however you want, and just move the code between them. With the predictability and structure, what came up in order, yeah? So things which each programmer loves, an order in his code. What about Java? GoTo is a keyword in Java. Feel free to open your laptops. Feel free to write down the GoTo in your IntelliJ, in your Visual Studio Code. It will get colored. But at the same instant, it will also be underscored with the red line, saying that this is a compilation error. A little Easter egg left by Ryan Gosling and his team. For me, it's a relief, to be completely honest with you. Yeah, so that we do not, that the Java is a structured programming language. But there are still people who hope that GoTo will be implemented someday. I hope they are not close to the blankets. But wise men will come to me and say, Konrad, what about exceptions? They are jumping in the code. Yes, using exceptions feels like jumping, but imagine a situation. You have a function A, calling function B, calling function C, and then C throws an exception within its block of code. It will be either nice function C, and it will handle its own exception, or will rethrow the exception upwards to its caller, to the function B. B handles it, or not. It throws it to A, and in the worst case, your JVM collapses because you haven't handled some exception. But another wise one will call and say, Konrad, we have labels in Java. Yes, there are labels in Java. They go to a nice close. However, there is one rule which rescues Java. The rule is that the labels cannot be defined, like you cannot jump with labels from one method to the other method. You can define labels, its scope, only within one method. There's also a third way, an old Java interface, which I leave you as a homework with, from which I could not defend myself. There you can call GoTo and it will work, just for your homework. Okay. As said, those things are cumbersome, but they do not hinder reasoning about the code. You do not have situations like this. A calling B calling C, and C jumps with the code flow out into the outer space. But you have A calling B calling C, C going back to B, B going back to A. But years have passed. We started to learn and start to work with the structured programming. Those structured programming were introduced in most of those languages which I mentioned. And to be completely honest with you, I cannot imagine working without structured programming. Even if I would be given the power of the go-to, I would use it to actually construct structured programming within my code. I'm too stupid and too wired already that to benefit from the go-to freely. And technology has grown also along the way. We have received more memory at our disposal, and most importantly, we have received faster CPUs and the CPUs with more cores. And it was not easy to grasp at first, but we started to write concurrent programs. I think tomorrow you have a talk with Heinz Kabutz, and Heinz is coming with some concurrency structures in Java. Highly recommend it to you. But we started to write concurrent programs, and we realized that concurrency is messy. And concurrency is problems. However, it helps to be more efficient. So we made our programs use every core that is on our CPU. And it started to be not enough for us. We've noticed that OS threads started to limit us. Yeah, that OS threads, which are expensive resource, which weight around 1 megabyte of memory with each thread. And therefore, it is quite exhausting for the system to spawn many threads for us. So we started to pull them. But even after that, we noticed that most of the time, what OS threads do is actually to wait for the input-output. So we started to think how to even get more threads, how to get even to benefit from the time of the waiting of those threads. And coroutines started to appear, coroutines started to appear, and finally in Java 21, virtual threads. Lightweight concurrency at our hands. But there is no free lunch. Yeah, as you know, in this industry, there is no free lunch, maybe except for the conferences. But what can you tell me about this code? It's Java 21 API. It's pretty new, 2 years old. But I think you already had a right amount of the presentations to be able to read this code. We are starting 2 threads, 2 virtual threads to be precise. What do we know about those threads? What happened to them? Have they finished? What was the result? Or maybe there was some exception. I don't know. What about you? But I got the feeling that I lost control over my code flow. I'm back again in the same place which I was 60 years ago. I was not alive there back then, but still, we as a software engineering industry are again in the same place like 60 years ago. And this is not my thought. This is the thought of these 3 guys, Sustrik, Smith, and Elizarov, which actually noticed that Go, async, and vthread is actually a new go-to. Lightweight concurrency and the ease of use of the lightweight concurrency is causing us to lose control over the code flow of our programs. So we are having, okay, nice function calls, but while starting those threads, we are jumping out of the code control into the outer space. And without quite cumbersome and quite complicated synchronization mechanisms, we cannot know what happened to our code. So they thought about the remedy. And the remedy is structured concurrency. Structured concurrency is happily rediscovering something that we discovered 70 years ago. It's generalization of the 3rd rule of the code flow, which I mentioned. The function called rule. We just call right now with the function A, not one function B. We are able to call multiple functions in parallel. But we are waiting for those functions to finish before finishing function A. This parent-child relationship with the concurrent running code from its caller allows us to answer what happened to my thread, because I will know it at some point, because I cannot finish my computation without my child coming back to me with the information what happened to him. Was it finished? And many others. What was the result? Yes, because the result needs to be given back to me. Why we want to have this? No more thread leaks. No more forgotten threads that was started somewhere and no one actually waited for them to finish. And if we are actually waiting for the program to terminate, no more cancellation delays. Thread ordering, it's becoming simpler because you just know when your previous thread has ended. And no more race conditions, because why to hurt yourself? Why to order things in a way that they can go in a concurrent way and cause race conditions? But as my friend Wojtek always says, there is always possibility to hurt yourself. So they are still possible, but they are more hard to do. So let me now show you latest proposal of the Java Structured Concurrency API, which is provided to you by Java language developers. It's a JEP 505. It's Java. It will be merged, hopefully, to the Java 25, but it is not yet. I just took it from the PR. But I strongly believe that this will be the actual last result of the structured concurrency, last outlook of it. So let's do it in a funny way. Imagine we are adults. Yeah. We want to meet together. And there are 5 of us. And actually, for me, it's a real-life problem. I have 4 friends. Wojtek, Michał, Max, and Maciej. And to be honest, once a year, we want actually to meet each other, to align about what's happening in our lives. And our wives given us 3 meeting times: Friday, Wednesday, and Monday. What our task is to actually choose time. Yeah, we have a simple task. We need to think. We need to pick one of the possibilities, announce it, and return it to our caller. And let me now show you the API. As choosing a meeting time is I would say, a very cumbersome task, the while true is there, because it will happen many, many times. But what starts afterwards is we actually are opening a thing called scope. You can think about scope as I will borrow this term from the Python. You can think about it as a nursery for your threads. A nursery in which you call all of your children to actually perform a task for you, and you wait for them. I will come to the parameters of the opening in a while. But what we do afterwards, after we have our scope in hand, which is, as you can see, a closable, auto-closable implementer, because we can use try with resources with it. It will alarm us if some thread will escape from our nursery. But okay, let's use it first. So we have we are taking our heroes, we are creating the task for them, and we put it into our scope. We are forking a thread for them. What we do afterwards, we collect the result of the forking, which is a subtask, just a subclass of this structured task scope. And we put them together into the task set. What we do afterwards, we are free to do any computations we want. Our children are running along with us and are computing what they need. However, we at some point, as their caller, arrive to the method called join. if someone is familiar with the thread API, fork and join should already sound familiar. However, join is a barrier waiting for the term specified while opening a thread. And this term, actually in this example, says await all. Yeah? So the join will release our computation only if all the children from, from our nursery will complete. And afterwards, I will scroll up a little bit. Afterwards, we are free to go through the subtasks we received, search for the ones which were successful. There are two other states, exception, so a failure, and unknown, because it is set when the task is still executing. And we are searching for the successful ones, and we pull the result out of them, and we put them together into the set. From the properties of the set and the properties of the record, because meeting time is a record, we know that if there will be only one meeting time chosen by all of our heroes, we will get single result and we will happily finish the tasks. Let me show you how it works. We are choosing time. Still no single result. But what is worth noticing for you is that the presentation of the chosen times is given only after each of us actually choose one of the times. But this may go forever, and let's play wives and say, okay, people, Monday is the only option. Sorry, so it's not demo demons. Okay, it went into read-only mode. Okay. So, just to prove that it finishes at some point, everyone has chosen Monday, we are happy, we are organizing a party. Okay, but what happens if we have another case? For example, we are organizing a party, and in order to organize a party, we need to run few different chores. Someone needs to buy chips, someone needs to buy drinks, someone needs to buy sausages, someone is setting up a PlayStation, and someone is lighting the barbecue. But as with all those tasks, something wrong may happen. For example, Żabka is closed. No drinks, no chips, no sausages. The only thing left is PlayStation, but the good party is nothing without those products. So we want to stop our computation at that time and say, okay, party is over, there's no party. In order to do this, we are changing the strategy given into the open method. Right now, we await all successful, or we are throwing an exception. And we, after the try with resources scope, we are catching this exception. And we are providing the full stack trace, full proper stack trace, so we are able to easily pinpoint what went wrong. Yeah. So let's see how it behaves. Right now, successful party. And the problem is, Max failed. He was not able to buy sausages. Wojtek was successful with drinks. Maciej was successful with chips, but Max failed. Where do you see Michał? Where do you see me? Nowhere, because we already received an interruption signal which caused our threads to stop and spare few precious CPU life cycles. Moreover, you can easily see that with the virtual thread goodie, which is full stack trace, which you can actually print out whenever something wrong happens. But you will come to me and say, okay, I have a scope, but I would like to start another scope. within my scope? Will it follow the same rules? And the answer is yes. Let me show you the example. After organizing a party, I don't know how about you, but we at the parties used to play FIFA. But when when was our times of playing FIFA, the FIFA was not that well built. It was more or less choosing two teams and playing against each other. There was no fancy tools to draw tournaments and many things like this. So what we did, we took a notebook, we took a pen, and everyone written down their own favorite teams. And we composed out of this a playoff ladder. However, as we had at the time only one PlayStation, and at the peak there was two PlayStations as far as I remember, we were playing this ladder in a way that you are not familiar from the TV. Yeah, it was not a situation when you had quarterfinals on one day, semifinals on another, and final on the third day. Our ladders were played completely asynchronously, and in most extreme cases, we could came up with the situations that we have a final team, like a team already for the final in one piece of the ladder, while in the other ladder piece, on their side of the ladder, they are still playing quarterfinals. So let me simulate it with the structured concurrency and with the recurrency. So we are playing 5-level tournament. If we are on the lowest level, we are picking two teams from this nice tool, Atomic Team Picker, and we are playing match within them. And if we are at the upper levels, we simulate this asynchronicity with structured task scope. We are opening a scope, we are waiting for all the children, and we are starting 2 threads within our scope, one to play a left-hand side of our ladder, and the one to play the other hand side of the ladder. We are afterwards joining and waiting for the result, and then we are playing match once the teams are chosen. Let me show you how it works. Round 0 starts to get mixed with the round number 1. Even number 2 showed up. So they were already at semifinals, while the other half was at the 1/16th of the final. And let's see who won. I actually made Poland won the World Cup. Yes, round 5. Where's round 5? Yay, Morocco won the World Cup. Just to show you it on the picture, because one picture says more than 1,000 words. Imagine a situation. We have a blue thread. It's spawning its children, 3 green threads. And one of the green threads, it's spawning its 2 children, yellow threads. So in the most extreme situation, yellow threads are running together with the green threads and are running together with the blue thread. But the leftmost green thread may only end when the yellow thread ends. And the blue one may only end when all of its children, so the green threads, also end. So where it is actually useful? It is useful, for example, the most iconic use case is that imagine you have an endpoint, which your client is calling, and you need to call S3 for some data, you need to call other service for some data, you need to go to the database from some data, and only if you have all those pieces, you can combine a result for your client and return it to him. And imagine writing it in the normal Java in a parallel way. How many concurrency constructs you would need to use to actually make it work? How many errors you would make along the way? Right now, for you, it's opening a scope, providing a strategy of awaiting. You can even write your own custom strategies. It's completely open sourced. So you can write your own strategies. And for example, whenever the database is not available, you can also react. And the task of downloading data from the database is not properly finished, but you can provide some different things instead. Second thing, downloading chunked files. For me, it was the first application of this. I used Java JCMD, and I just downloaded 100 gigabytes of chunked data on my laptop, combined it together with Java, and outputted a nice zip out of it, and some other parallel transformation of elements. What is it for from the point of view of the user? It's to simplify concurrency control and introduce parent-child relationship to tasks, which makes it easier to debug problems related with the parallel execution of those tasks. What is it not for? It is not to replace any concurrency constructs in Java. Java util concurrent is staying there forever. And moreover, it is not to replace futures, reactive Java, you name any other technology. It's just another proposal. And this is not the only one approach to the structured concurrency. I don't know if Adam Warski is in the room. However, Adam Warski and his team in the software mill are developing a library called JOGS, and it's a little bit different approach to the structured concurrency, but it will be more familiar, for example, for the people who are coming to Java from the Go language. Okay, we still have some time, so I will give you one more bonus. There's another API coming in the Java 25 with its also 6 review. It's specified in the JEP 506. So imagine the situation that most of us have, that we want to share data in our computations, without the need to pass it through the stack trace, to pass it through the method params. We just want to have a widely accessible value and share it among our computation. And you will say, okay, sounds familiar. We already know this. It's called thread local. Yes. However, thread locals have their problems. They're mutable. There's a set method on each thread local. I don't know who remember log4j shell vulnerability. Yeah. And this vulnerability combined with the mutability of the thread locals, which are widely used by the different frameworks, caused a very big havoc among the software community. It was, I think, the Christmas time. I think it was just before the Christmas time. So I remember sitting there and fixing those things till 1 a.m. just before Christmas. However, I did not caught Santa along the way. So they are mutable. So anyone can set your value for your thread local anywhere from the code. Moreover, they live as long as thread to which they are attached is living. And as we already know, the threads are heavy resource. So what we do with the threads? We pull them, we reuse them. And this may cause problems, because who is cleaning up after himself when it's coming out of the kitchen? No one. We are always forgetting about this. So there are people who are not cleaning up the thread locals. And these threads with these thread locals are now being reused because the threads are pulled. And for example, imagine that those values are some tracking information, and you are debugging a problem in production. And these are the moments when you actually lose her. And the problem with the thread locals is inheritance. because the standard implementation of the thread local is causing that whenever your thread is spawning its children, the children inherit the value of the thread local. And imagine you are holding something heavy in this thread local. You are given a straight recipe for a slowly bleeding memory leak. But now we have virtual threads. And thread locals are working in virtual threads. And we can have millions of virtual threads. So this slow bleeding memory leak is becoming a gore spectacle. Okay, mesh it. Okay, what we actually use thread locals for? We just want to share a value within a thread, but we do not want to share it within the thread. We want to share it through the stack trace, through the method calling each other. We want to have one general value to which each of these methods in their code can reach and read current state. As it happens, the threads are actually executing our methods. So someone connected the dots and said, okay, let's attach it to the thread. But this is not what we meant there. What is the alternative to the thread locals? It's called Java Scoped Values, JEP 506. And I think it's already in its final form. The API will not change, so I would like to show you. So a scoped value is a value that may be safely shared to methods without using method parameters. And let me show you how it looks like. We are painting rooms for our company. And let me show you the example. Painting rooms. Okay. So what we do, we have 6 types, like 6 colors of paint. I'm a man, so I only know that much colors. And we have a scoped value called paint, which is actually holding our currently used paint. What we do, we start painting, and our CEO said, okay, I like white. I need to walk into our company, and the room which I walk into should be white. But afterwards, do whatever you want. And he said, okay, let's go. What we do in each of these steps, we are checking whether we should end, whether we are at the end of our company. We are painting room, and what painting room is actually is just reaching to the scoped value and getting it value, getting actual value from the scoped value, however it sounds. If after we paint our room, we are asking ourselves, maybe we should change paint. And we are calling again scope value, where paint will be from the different color, and we are running our stack trace down lane. If not, we are just following down lane. And let's see how it will behave. Painting rooms, go. Whoa, that was fast. First room, white. But then we said, okay, we are going blue. We are painted it blue. Then we said, okay, we go red. We painted it red. We go white. We painted it white. We said we go yellow at the last room. However, there was no more rooms to color. And then we started to go back. As we decided, a white is being restored. Then, in the upper layers, we remember, okay, these rooms at this level should be red. So we are restoring red, 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 blue at the topmost, and then we are going with the rest of the tree. And some change to the black. Probably IT came in. Okay, where to use this thing? Right now, we should pass in that manner authenticated user for each of our requests. We should pass in that manner a transaction started within some scope. Passing logging information, no more leaking request IDs. Passing metrics registry. It solves for us those situations very nicely within any spilling over. But every rose has its thorn. Still, they did not solve the memory cost. It's smaller than with the thread locals, but it's still there. They're suggesting. Thank you. That was all I wanted to show you. Q&As. Let me go to Slido. Was there? No questions. No, there are, sorry. So first of all, are these issues exclusive to whitelisted? No, they are not. And if you would pay attention to the code closely, you would notice that in the example of, I think in all of the examples actually, I'm using a thread factories construct, and I'm providing here a virtual threads. But it's not the only option. It also works with the platform threads, as well as with the virtual threads. So it's not exclusive to the to the virtual threads. However, with the virtual threads, problems which I described here are much more visible than with the normal threads. Yeah? Okay, let's go to Slido. What do you think about the risk of concurrency together with DB connections? For example, depletion of the connection pool. Yes, this may be a problem. With the virtual threads, you can run into this problem more easily, but still pooling is something that is, how to say, recommended for the heavy things like connections. How does this compare to Kotlin Structured Concurrency? It's pretty much similar. However, Kotlin is having a little bit more ceremony around this, in my feeling, personal feeling. However, I do not know that well Kotlin coroutines. When do you think structured concurrency will finally become a permanent feature? Actually, I was hoping for that 4 weeks ago, like when the Java 24 was released. Like four or 5 weeks ago, when Java 24 was released, I actually at some point read at the JEP that it's final, that it will be in Java 24, but then suddenly, okay, it is not there at the day of the premiere. And Alan Bateman started a discussion around it and actually proposed this API, which is, I think, better from what we had there in Java 24 and other proposals. If there are any more questions, I'm still here. I will be throughout all the conference. Luckily, my wife allowed me. And yeah, thank you all and have a good evening. Would it be hard to book to Java 17 make library? You can actually start already using it in Java 17. You just need to go with enable preview, and however the API will be different. Yeah, it still will be there. It still will be extensible. It will still run both on the virtual threads and platform threads. However, it will look different. You will not have this strategy called joiner in this API. You will steer the strategy by providing different implementation of the structured task scope. At this Java 17, as far as I remember, you have shutdown on failure, which is await all successful or throw, and you will have shutdown on success, so await single successful thread, and you will have await all. And you will be providing different strategies by inheriting from the structured task scope. Okay, if that's all, thank you very much. Have a nice evening.